In this lesson, we will learn and apply the sine law and cosine law to solve problems involving non-right triangles. So up until now, we've been looking at right-angled triangles in solving unknown sides and unknown angles. All triangles are not right-angled triangles, so we need to explore how do we solve triangles that are not right-angled triangles. And that's where they came up with the sine law and the cosine law. So the sine law, let's recall, if a triangle is oblique, that means no right angle, we can use the sine law to solve its missing components. The sine law can be used to solve oblique triangles with a corresponding side and an angle. So if we are given two angles in one side, so in this case it would be angle B, angle C, and side B, angle, side, or if we're given an angle, a side, and angle, as in angle B, side A, and angle C in the second triangle, or we can figure out two sides and angle opposite these sides. So if we're given side, angle, meaning side C, side A, and angle C. Notice angle C, the opposite side of angle C is labeled as lowercase c. All angles are always capital. Opposite sides are lowercase of that angle. So the formula for cosine law will always be provided to you. Given triangle ABC, if a side is missing, we would set up the ratios A, side A over sine of angle A is equal to side B over sine of angle B, which is equal to C over sine of angle C. However, if you're given a triangle ABC, if an angle is missing, we would just take those reciprocals, and notice we would start with sine of A over side A equals to sine of B over side B, which is equal to sine C over side C. So looking at example 1, if we're given triangle DEF, solve the triangle, which means determine all the sides and all the angles. We want to round to the nearest whole number and degree. So both the side lengths to the nearest whole number and the angles to the nearest degree. Okay, so before we can even start using the sine law, we do want to make sure we label all sides and angles properly. So the triangle has all the angles already labeled, so we have to make sure to label the corresponding sides. So opposite of angle D would be side D, opposite of angle E would be lowercase e, and opposite of angle F, lowercase f. So that is very critical. We do that first. So then we would set up the ratio. The sine law tells us sine, because we're doing the sides, I would start with the sides first. So E over sine of angle E is equal to side D over sine of angle D, F over sine of angle F. The order does not matter, but you do have to be consistent. If we're starting with the sides, they would be the numerator in each case, and with the ratio, we'd put the sine in the denominator. So you have to be consistent. You can't mix and match. All the sides on the top, all the ratios on the bottom. Okay, so the order again, D, E, F, F, E, D, that does not matter. Okay, so with that in mind, let's substitute the information we do have. We know that there's no information there. We know side D is 15, and we know that angle D, which is capital D, is 95. So sine 95 degrees is equal to F, which we do know, which is 11, all over sine of angle F. So we're missing side D, side E, and angle F. Okay, so because we set up our sine law, we can only use two at a time. So if you notice, the first does not provide us with anything, so we are going to use these two ratios to help us out. Or we should say proportions to help us out. So because we are looking for angle F, we're going to cross multiply. So this becomes 15 sine of angle F is equal to 11 times sine of 95 degrees. So you would just cross multiply and isolate for sine of F, because if we divide this side by 15, divide that side by 15, we're left with 11 sine 95 degrees all over 15. Now again, in this case, like all the other ratios, when we're trying to figure out the angle, we're going to separate the ratio from the angle, bringing that over. So it would be angle F is equal to the inverse of sine at. Okay, so again, if we're looking to figure out the inverse, so keep in mind, we do have to use shift. So you have to know your own calculator. So shift sine. We're going to figure out that angle F is about, which would be about, we're rounding to the nearest whole number, which is 47 degrees. Now, if we know that angle F is 47 degrees, we can determine angle E by just using angle sum of a triangle theorem, and we know that angle E is going to equal to 180 minus 95 minus 47. Again, we did round angle F, so angle E would also be rounded to 38 degrees. Okay, so now that we have angle E, we can use that information, put it back into the sine law to solve for side E. So E over sine of angle E, which is 38 degrees, is equal to, we're going to use 15 over sine. Okay, so although we know what angle F is, and we did round a bit, it's always best to use the information that was provided in the original question. So in this case, we're going to cross multiply. So it's going to be E times sine of 95 degrees is equal to 15 sine 38 degrees. Divide this by sine 95. What I do to one side, I do to the other. So E is going to equal to 15 times sine 38 degrees over sine of 95 degrees. Okay, when you're inputting this into your calculator, it's best to put brackets around your numerator, 15 sine 38, close bracket, and divided by bracket sine of 95. So we should get that if we round to the nearest, so you get 9.27, but we're rounding to the nearest meter in this case, which would be about 9 meters. Mhm. All right, moving on to B, same idea. We want to make sure that everything is labeled properly. So again, across from angle C would be side C. Across from angle B is side B. Across from angle A is side A. So again, capitals for the vertices, so the angles, lowercase for the sides. So that's very critical. We want to make sure that it's universally known that all the angles are always in capital, all the sides are in lowercase. Now, first thing we want to start with, because we do need to determine solve the whole triangle, we're going to say angle C is equal to 180 minus 63 minus 49 degrees. So angle C would equal to 68 degrees. Okay, so with that in mind, then we have that C is 68 degrees. We're going to set up the sine law. We're going to say sine of A, which is 63 degrees, over side A is equal to sine of 68 degrees over 78. And then we have the sine of angle C, which is, B, which is 49 degrees over B. Now, I kind of arranged this on purpose because I know the information of the side and the angle I do have. I put it in the middle. I didn't go A, B, and C just for that reason, because now what I'm going to do is calculate, because I need both of these side lengths, 2 at a time. I'm going to cross multiply and solve for the unknown side. So this would be A times sine of 68 degrees is equal to 78 times sine of 63 degrees. We need A by itself. A is going to equal to 78 times sine of 63 degrees all over sine of 68 degrees. So again, as I was mentioning with the earlier problem, treat the numerator and the denominator separately, and putting brackets will help avoid any calculation errors. So when we take 78 sine 63, so 78 sine 63, and we divide it by, keeping that in brackets, divided by bracket sine of 68, A is about, and we get 74.956564. So then we know A is about, we're rounding 75. And don't forget the units. In this case, it is meters. Okay, now we're going to use the second two ratios. We're going to say sine of 68 degrees over 78 is equal to the sine of 49 degrees over B. So cross multiplying is going to be B times sine of 68 degrees, 78 sine 49 degrees, divide that by sine 68. B is equal to 78 sine 49 degrees all over sine of 68 degrees. No, so we go 78 times sine of 49, brackets divided by bracket sine of 68 degrees. So B is equal to 63.490479. Therefore, B is about 63 meters. Okay, that way we have fully solved the triangle. We've determined all the angles and all the sides. In example 2, we have in triangle ABC, given that angle A is 57 degrees, angle B is 73 degrees, and side C is 24 centimeters, find the length of B to the nearest centimeter. So often we're not given the triangle, we have to draw it. It's okay not to draw to scale, I'll try my best. But we have A is 57 degrees. Okay, so A, we'll say A, B, and C, opposite angle A, side B, side C. Angle A was 57 degrees, angle B is 73 degrees, and side C is 24 centimeters. Okay, because we're already given the two angles, we can determine the third angle by taking 180 minus 57 minus 73 degrees. So angle C is going to equal to 50 degrees. Okay, so setting up our sine law, we know sine of 50, and I'm going to start there because we have side C, which is over 24, is equal to sine of angle B, which is 73 degrees, all over side B, which could equal to the sine 57 degrees over A. Now, since we don't need to calculate that, we don't even have to include it. Okay, once we have our ratio, we can cross multiply. So B times sine 50 is equal to 24 times sine of 73 degrees. So remember, those dots indicate multiplication as well. So we're going to divide this side by sine of 50 degrees. We're going to divide that by sine of 50 degrees. And we're left with B is equal to 24 times sine of 73 degrees all over sine of 50 degrees. So we have 24 times sine of 73. Press equals, and we're going to divide that by bracket sine of 50. And we are left with B is equal to 29.9608. So B is approximately, because it's to the nearest centimeter, would be rounded to 30 centimeters. Okay, so therefore, the length of side B is about 30 centimeters. Okay, looking at example 3, we have the angle of elevation to the top of building C from 2 points A and B on level ground are 50 degrees and 60 degrees respectively. The distance between points A and B is 30 meters. Points A, B, and C are in the same vertical plane. Find the height of the building to the nearest meter. Now, if we're talking about the height, we already have a H designated there, but it is an unknown. So we're going to say let H represent the height of the building. Now, we know the buildings should be perpendicular to the ground, which it's indicated there. So if you look at this triangle, and I'm just going to just highlight it, we actually have two different triangles here. We have this right angle triangle, which we need eventually to figure out the height. But if you look at that triangle, we're missing two sides and an angle. So not enough information to solve that triangle. However, we are given another triangle. So I'm going to just highlight that in red. This would be A, B, and C. Okay, so from there we can determine quite a bit. We know if this angle in CB, and we'll call this, say D, because it's not labeled. We know that that angle given is 60 degrees. So if that is 60 degrees, if this is 60, this angle here has to be 180 minus 60. So if we took 180, so angle ABC is going to equal to 180 minus 60 because that's that straight angle theorem. Those two together have to equal to 180. So angle ABC is going to equal to 120 degrees. So if this is 120, I'll give myself some more space. If that's 120 degrees, we can easily determine angle ACB. So angle ACB then is equal to 180 degrees minus 120 degrees minus 50 degrees. So angle ACB is going to equal to 10 degrees. So that helps us out because the more information we have on this triangle will help us determine that common side. So if you can notice, there is a common side BC on both triangles. If we determine that length, that'll help us determine the height of the building. Okay, so with that in mind, so there's a game plan. So we're going to say in triangle ABC, determine side BC. Okay, which is denoted, as you can tell, it's already labeled for us, which is great. Side A. Side A. Or we're going to say side A. So what I like to do is take apart the triangles. It's a little bit easier to solve. So we have that non-right angle triangle. We have A, B, and C. We know this is 10. We know this is 120. We know this is 50. We know this is 30 meters. We are trying to figure out that unknown side. So again, it's not a right angle triangle, so we're going to be using the sine law. So we know sine of 50 degrees all over A is equal to, because we are given side C, so we have C, that was B, sine, we're going to say of 10 degrees all over 30. And that'll help us to figure out that common side A. BC, if we looked at the vertice names. So cross multiplying would be A times sine of 10 degrees, 30 sine 50 degrees. So we're going to divide this by sine of 10, divide that by sine of 10 degrees. So A is going to equal to 30 times sine of 50 degrees all over sine of 10 degrees. So A is going to equal to, again, 30 sine 50. And remember, keep that in brackets. We don't want to calculation errors because we didn't put it into our calculators properly. So A is equal to 132.3442238. And because we're rounding to the nearest meter, A is about 132 meters. Often in triangles and non-right angled triangles, we're given information where the sine law cannot be used. There was just not enough information to use the sine law. So they came up with something called the cosine law. The key concept is the cosine law can be used to solve oblique triangles given these specific conditions. So if you're given two sides in a contained angle, meaning two sides and the angles that those two sides create, then we're using the cosine law. That's the side, angle, side. If, however, we're given all three sides, we're also able to use the cosine law. So just as a reference there, sometimes the sine law may not be sufficient to solve oblique triangles, hence that's why we use the cosine law for these given conditions. Sometimes a combination of both laws may be required. So the cosine law tells us, now if we're going to figure out the side, so we have the formula given triangle ABC. If a side length is missing, use the following formula. So notice, again, very critical to identify. Lowercase always represents the side of the triangle. The capital letters always represent the angle. So if you're solving for a squared is always equal to the other two sides, b squared plus c squared, minus 2 times the given sides, b and c, and then cosine of angle A. Notice the angle is required of the side that is missing. Okay, so likewise, just rearranging that same law for the different sides. So if you needed b, it would be squared equals a squared plus c squared minus 2 times the two sides given, a and c, cosine of angle b. Notice angle b, of course, is the angle opposite the side that is unknown. And likewise, rearranging for c, c squared is equal to a squared plus b squared minus 2ab times cosine of c to solve for c. If, however, we need to determine the angle measure, that exact cosine law is now rearranged so that we are now solving for the angles. Now, keep in mind, all these laws would be provided to you. You just have to know how to use them. So let's move on to example 1, where again, in all of these triangles, it is so critical to label all sides and angles properly. So again, there's angle A. So across from angle A is side A, angle B across from angle B, and across from angle C. So notice we're given all three sides. So the rule of thumb is if you're given all three sides or two sides of the contained angle, you use the cosine law. If you don't have that, automatically you're using the sine law. That's probably the easiest way to remember which law to use. So you're given all three sides or the two sides and the angle that those two sides make, then you know you're using the cosine law. Otherwise, you're using the sine law. So in this case, it says determine angle measures to the nearest degree. So of course, we need to use the version of the cosine law where we're solving for angles. So let's start with angle A. So we're going to say cosine of angle A is going to equal to, well, the other side's b squared plus c squared minus a squared all over 2bc. So then we have cosine of angle A is equal to b, which is 39 squared, plus c, which is 51 squared, minus a squared. A is 43 all over 2 times b times c. Cosine of angle A is equal to, taking 39 squared plus 51 squared minus 43 squared, which is equal to 2,273 all over 2 times 39 times 51, which is 3,970. And again, as earlier with the trig ratios, when we need to separate the angle from the ratio, bring it over the other side. On your calculators, you're pressing shift and cos, so angle A is equal to the inverse of cos. I wouldn't round too soon. Leave these as exact in fraction form, and then round in the very end. So inverse of cos at 2,273 divided by 3,978. We do get angle is 55.15260.265. We're rounding to the nearest degree, which would be 55 degrees. And we did round, so we're going to put a dot on top. Okay, so we know that A is 55 degrees. Now, again, it doesn't matter which one you choose. We're going to choose B. So we're going to say cosine of angle B would equal to, again, because we're solving for angle B, that means we're going to take a squared plus c squared, and you subtract the side of the angle that you are solving for, so 2ac. So cosine of angle B is equal to a, which is 43 squared, plus c, which is 51 squared, minus b, which is 39 squared, all over 2 times 51 times 43. So cosine of angle B is equal to 43 squared plus 51 squared minus 39 squared, which would be 2,929. 2 times 51 times 43, which would be 4,386. We're separating again the angle from the ratio. Bring that over to the other side. Make sure to do the inverse. Again, shift cos on your calculators. The inverse angle B is equal to cos which would be about 48.10199,355, which is about 48 degrees. Don't forget the units as well. So now that we have the two angles to figure out the third, we can just use angle sum of the triangle theorem, and we know they all have to equal to 180. So it's going to be 180 minus 55 degrees minus 48 degrees. So angle C is about 77 degrees. So therefore, the angle measures are about 48 degrees, 55, and 77 degrees respectively. Excellent. So moving on to example 2, we're given again two triangles together. Now with that in mind, we always want to see where is the information that we have, and then you always have to have a plan. You can't just start throwing numbers around. We know ultimately we need x. So that's in triangle EGF. Okay, so if that is the case, we don't have enough information for the cosine law, because looking here, if looking at the cosine law, we would need all three sides. We don't have that. Or two sides in the contained angle. Well, we don't have any sides, so that doesn't work. However, if looking at triangle EFG, we do have two sides and the contained angle. So if, and there again, there's that common side of EG. So because we're given two sides of the contained angle, we can use the cosine law. So I'm going to say step one, determine side EG in triangle EFG using the cosine law. Okay, with that in mind, if we have that common side EG, then we are able to use, so step 2, because we would have a side and the angle side angle, we can determine side of, the angle H in order to use the sine law. So we're going to say step 2, determine x using, so x in triangle EGH using the sine law. So it's better to plan your steps before you start solving. So in triangle, so I like to take them apart as I mentioned earlier, just so that we can label everything properly. When there's too many numbers, it's hard to label everything. So that would be side F, and that's what we need. That would be side G, and we know this is 93.1 degrees. Okay, so as indicated earlier, we have two sides and the angle that they two make. So that means that we can use the cosine law. So we're going to say f squared is equal to e squared plus g squared minus 2eg cosine of angle f. Okay, so f squared is equal to 8.7 squared plus 9.5 squared minus 2 times 8.7 times 9.5, and then cosine of 93.1 degrees. Now, I think we can just put this all into our calculator. So 8.7 squared plus 9.5 squared minus 2 bracket 8.7 times 9.5 times cosine 93.1. We should get that f squared is equal to 174.8792278. We do need f by itself, so we're going to take the square root of both sides. F is equal to 13.2241910. And because we're running to the nearest tenth, F is equal to about 13.2, and our units are meters. Okay, so this is 13.2 meters. Now, in order to figure out what side X is, we do need the angle opposite side, in this case, side H. So with that in mind, we need to figure out H. We can use all the angles in a triangle have to equal to 180. So using the angle sum of a triangle theorem, we can take 180 minus 31.2 degrees minus 50.1 degrees. So angle H is equal to 180 minus 31.2 minus 50.1, which would be 98.7 degrees. Okay, so with that in mind, we now have all three angles and the sides. So let's take that apart. And we have this triangle, which is H, G, and E. This is 31.2 degrees, 50.1 degrees, 98.7 degrees. This is X. This is 13.2 meters, and that'll allow us to solve. So let's label again, little g, little h, little e. So we're going to say, because I used X, we're going to say sine of X over sine of 31.2 degrees is equal to 13.2 all over sine of 98.7 degrees. And then cross multiplying, we would say X times sine of 98.7 degrees is equal to 13.2 times sine of 31.2 degrees. Divide this by sine of 98.7, sine of 98.7 degrees. X is equal to 13.2 sine of 31.2 degrees all over sine. Okay, so X is equal to 13.2 times sine of 31.2. Don't forget to press equal, treat the numerator separately in brackets, divide that by sine of 98.7, which would be 6.917550644. So X is approximately 6.9, don't forget your units, meters. Example 3, we have the Leaning Tower of Pisa is 55.9 meters tall and leans 5.5 degrees from the vertical. If his shadow is 90 meters long, what is the distance from the top of the tower to the top edge of its shadow? Assume that the ground around the tower is level. Round your answer to the nearest meter. Okay, so let's get that visual. First, let's start by Leaning Tower of Pisa is 50.5 meters tall. It leans 5.5 degrees from the vertical. Its shadow is 90 meters long. So let's draw that. It's always good to have a drawing to understand what is going on. So we know the tower is 55.9. So we're going to, this is 55.9 meters. Okay, we know shadow is always on the ground. So let's do that. Now it does say that it leans 5.5 meters from the vertical. So what that means, if I was to draw this would equal to 90 degrees, right? So that means this angle in here has to be 5.5 degrees. Well, we know if it was straight, because that's leaning tower, if at one point it was actually perpendicular to the ground, we know that would form a 90-degree angle. So the angle inside this triangle, we know this would be the shadow, which we said was 90 meters long. We need to know from the tip to the tip of the shadow. This is my x. So I'm going to say, let x represent the distance, because that's our unknown, right? Whenever you use a variable, we want to make sure that we have a let statement. What does it represent? From the top of the tower to the top edge of its shadow. If you're not sure, just look at your unknown, and that would be what your variable would represent. So if we know this is supposed to be 90 degrees, we know then theta in here should equal to, theta is equal to 90 minus 5.5 degrees. So that means theta is equal to 84.5 degrees. So if I took this apart, and again, it's not drawn to scale, we can say this is 84.5 degrees. We know this is 55.9 meters. This is my x, and this would be the 90.0 meters. So looking at the information provided, we have two sides and the contained angle. So we know the two sides, so 55.9, 90 degrees the shadow. So it's the tower, the shadow, and they have the angle between. So this is where we can use the sine law. X is what we're trying to figure out. So we're going to say x squared is equal to 55.9 squared plus 90 squared minus 2 times 55.9 times 90.0, the cosine of the angle 84.5 degrees. Now again, we could just put that right into our calculator. So x squared is equal to 55.9 squared plus 90.0 squared minus 2 times 55.9 times 90. And then, of course, you can multiply that by the cosine of 84.5 degrees. So we should get x squared is equal to 10,260.41004. And of course, to get rid of the square, we square root both sides. So x is equal to, if we take the square root, we would get 101.29 36832. However, we're rounding to the nearest meters, so x is about 101 meters. Now again, don't forget these are word problems, so we want to make sure we answer the question. So therefore, the distance from the top of the tower to the top edge of the shadow is about 101 meters. And there we have it.